In this video, we're going to look into two more indeterminate forms. One of them is called indeterminate product, which is in the form of 0 times infinite or infinite times 0. Say if I have two functions, f times g. If f goes to 0, g goes to infinite, I always can write one function as reciprocal function, flip it to the denominator. So when you revisit this function, look at this, as f goes to 0, 1 over g also goes to 0 because g goes to infinite. Now I have a 0 over 0 form. This is how we change indeterminate product to 0 over 0 type or infinite over infinite type. If I flip f function, I can write it as g over 1 over f. Then this reads as infinite over infinite. So this also can be rewritten from 0 times infinite to infinite over infinite. So this is one of them. The next one is what we call indeterminate difference. So just because you have something big subtracted something big, you get to know the outcome. In fact, the outcome is indeterminate since we don't know which item goes to infinite faster. Let's look at one of the examples. When a function is given, we're going to look into what's going on with this function. Is it one of the indeterminate forms as x approaches 0 from the right hand side? As x approaches 0, we know sine of x goes to 0 and the natural log of x goes to negative infinite. Now again, recall this visual. As x approaches 0 from the right hand side, look at the natural log function goes straight down. So now we know this is 0 times infinite form. Once I have an indeterminate product, I'm going to flip one of them so that I can have a 0 over 0 or infinite over infinite form. In this case, I decided I'm going to flip sine function. And I can rewrite this as natural log of x over cosecant of x. And let's check. As x approaches 0, natural log of x goes to negative infinite, cosecant of x goes to infinite. So I actually have infinite over infinite form, and therefore we get to use L'Hopital's rule. And L'Hopital's rule stated we take the derivative for the top function and the derivative of the bottom function. And at this point, I think I would rather just simplify before looking into. And this is going to be negative 1 over x times cosecant of x times cotangent of x. Now this is getting a little bit more complicated to see, so, and harder actually to see, because x goes to 0, cosecant of x is undefined, going to infinite, and you have x goes to 0. Well, this is not good because it's complicated. So I am going to change all functions in terms of a sine and a cosine. So I have x times 1 over sine of x and a cosine of x over sine of x. Or as x goes to 0 from positive side, I have a sine square. Sorry, there's a negative sign. Over x times cosine of x. And now we check again. As x goes to 0, the numerator will go to 0. Sorry, there's a parentheses. The denominator is also going to 0. So I have a 0 over 0 form. Therefore, we get to use L'Hopital's rule again. As x goes to 0, we take the derivative for the top function, 2 sine of x cosine of x. At the bottom, we use a product rule, cosine of x plus x times negative sine of x. As x goes to 0, and we're going to check, the numerator is going to go to 0 because sine of x goes to 0. The denominator, as x goes to 0, this goes to 0, but cosine x goes to 1. So I have 0 over 1, which is 0, and that is the limit for this function. Let's look at next one. And as x approaches 0, let's check. Cotangent of x as x approaches 0 is going to go to infinite. 1 over x is going to go to infinite, so I have indeterminate difference. Whenever we have indeterminate difference, we need to combine these functions. Combine these functions into some quotient form so that hopefully I get to see infinite over infinite or 0 over 0 type, so that I get to use L'Hopital's rule. With that in mind, I change cotangent function as a cosine of x over sine of x minus 1 over x. We combine these two functions by finding common denominator, which is x times sine of x. Multiply the first term, top and the bottom, by x. Second term, top and the bottom, by sine of x. And then we check again. As x approaches 0, we actually have 0 over 0 type. Therefore, we get to use L'Hopital's rule. And the L'Hopital's rule stated I need to take the derivative for the top. I gotta use the product rule to find the derivative of x times cosine of x. Cosine of x minus x sine of x minus the derivative of sine, which is cosine of x. In the denominator, product rule again. So that's going to be x and sine of x plus x times cosine of x. Again, I would like to simplify before I move on. So I can cancel the cosine from the top. I have a negative x sine of x over sine of x plus x cosine of x. As x approaches 0, let's check. And the numerator is going to go to 0. In the denominator, it also goes to 0. So I have 0 over 0 type. Therefore, we get to apply L'Hopital's rule again. As x goes to 0 on the top, I need to use product rule. Negative sine of x minus x, x cosine of x. In the denominator, I have a cosine of x as derivative of sine, and the plus product rule on x times cosine. So I have a cosine of x minus x sine of x. Let's see. We are going to check to see whether I still have an indeterminate form. As x goes to 0, the numerator is going to go to 0. Because the sine x goes to 0, and there's a multiplier of x which goes to 0, the whole numerator will go to 0. What about the denominator? Denominator, as x approaches 0, I have 1 plus 1 minus 0, which is 0 over 2, as 0 is no longer indeterminate form, and in fact, we found the limit of the function.